This video covers the lesson or the answers for the Jeopardy game we played in class in preparation for the series test. So first of all, we're going to look at geometric. With geometric, remember, all you have to do to figure out if it converges or diverges is look at the r. That's whatever's being raised to the n. So in this very first example, our r is 5/6. And since it's less than 1, this one converges. If the absolute value of r is less than 1, it converges. If it's greater than or equal to 1, it diverges. So I'll go and write that down. Less than 1, or absolute value of r, less than 1, converges. Absolute value of r, greater than or equal to 1, diverges. Okay, so if r is less than 1, converges. Greater than or equal to 1, diverges. So in the second example, our r is 5/4. That means it diverges. Okay, now 3 is a little tricky. You have to be careful because 8 is not being raised to the n. So 8 is not part of the r. You actually need to look at this and rewrite it a little bit as 8 times 1/5 to the n. So pull 8 out front, and then you can raise the 1 and the 5 to the n. So 1/5 is less than 1, which means this one converges. On number 4, pi is 3.14. E is 2.71. I'm rounding, but we can tell very easily it is bigger than 1, which means this will diverge. Okay, now on number 5, I know the exponents aren't quite the same, but the truth is it doesn't matter. They're both being raised to powers with n, so we just treat this, as far as the r is concerned, as 5/9. There is a way to rewrite it so that power is exactly the same, but that doesn't really matter as far as converge or diverge. Since 5/9 is less than 1, this one converges. Okay, second category was telescoping and geometric sums. So we need to find the sum. For a geometric series, if we're starting at 0, we use the formula a over 1 minus r. So for this one, it'll be 3 over 1 minus negative 0.8. So we get 3 over parentheses 1 minus negative 0.8. And we get 1.6 repeating. I believe that's 5/3. Yes, 5/3 it is. So the sum of this geometric series is 5/3. Number 2 asks if this converges or diverges. It is a telescoping series, so it automatically converges. Telescoping always converges. Number 3, whenever you're asked to find the sum of a geometric series and it starts at 1, you need to use the formula a over 1 minus r minus a. So we will have 4 over 1 minus 1/3 minus 4. So 4 over parentheses 1 minus 1/3, close the parentheses, and we subtract 4 from that whole amount. So the answer will be 2. Number 4 is also telescoping. You can tell that this one is just a little bit behind this one. They'll catch up to each other. So this is also telescoping, which means you automatically converge. Now number 5 is a trick question. It says to find the sum, but we cannot find the sum when it's a divergent series. So if you want, you could say the sum's infinity. It at least continues to grow forever and ever. So this one diverges. It doesn't have a sum. Third category, the nth-term test for divergence. The nth-term test says that if you take the limit as n goes to infinity and you don't get 0, then the series diverges. Now if you do get 0, you can't use the nth-term test. It just is inconclusive basically, and for the sake of the category, we'll say inconclusive, but on your test tomorrow, if nth term doesn't work, you'll need to try something else. So on this one, this first one, the powers are the same. They're both n squared, so we just would use the coefficients. So the limit as this goes to infinity would be 9/2. Since that's not 0, that proves this diverges. Okay, number 2, if we were to take the limit as n goes to infinity, we have something bigger on the bottom. So the limit's going to be 0, which means we can't use the nth term test. So the nth term test is inconclusive. Now if you're curious, on the test tomorrow if you had one like this is a p-series. Since there's the 36 and the 5 are just coefficients, that doesn't affect whether you converge or not, but this is n to the first on the bottom, so it would actually diverge by p-series. Okay, this next one, where you need to take the limit. Well, if you remember le pouf, remember L is log, P is polynomial, E is exponential. Oh, sorry, le pouf, there should be an F there. F is factorial. L is the slowest, factorial is the fastest. And if the faster one is on top, you go to infinity. If the faster one's on the bottom, you go to 0. Well, on top we have an exponential, and on the bottom we have a polynomial. So exponential is faster. That means the top is faster, so our limit is infinity. Infinity is not 0, so this one will diverge by the nth term test. Okay, number 4, we have the opposite. We have a polynomial on top, and we have an exponential on the bottom. So this one is actually going towards 0, which means nth term is inconclusive. And I think the only way we could solve that one would be a very, very, very massive integration by parts, and there's just no reason to worry about it. So we're not going to. All right, the last one, number 5. Actually, we may know how to do number 4 with our tests that we'll learn next unit, but we're not going to worry about it now. Number 5, when we take the limit, we also get 0, because on top we have an exponential, and on the bottom we have a factorial. Factorial is faster. That means the bottom is faster, so the limit is 0. So once again, the nth term test is inconclusive. We'll learn some tools that will help us figure that out, figure out whether it does diverge or converge later on, but we don't know any right now. P-series in the integral test. So first of all, converge or diverge. With P-series, if the power is greater than 1, you converge. If the power is less than or equal to 1, you diverge. Now forgive me, this should say n to be consistent here, not x. But this has a power of 4/7, so that is less than 1, so this one would diverge. It is a P-series and it would diverge. Okay, number 2 is the integral test. So let's look at that and see if we can figure that out. We would have to rewrite it as the limit as b approaches infinity of the integral from 2 to b of natural log of x over x. Our u would be natural log of x because it is always natural log. Or u is always natural log. The derivative of that is 1 over x dx, which is actually a perfect match for what we have. Because if you need to, you can rewrite this and see that it's the same as this. So we have u du. Now we're ready to take the antiderivative. So we do the limit as b approaches infinity of 1/2 u squared from 2 to b. I'm going to go ahead and plug in the u, so 1/2 natural log of x squared from 2 to b. So now I need to plug in my top minus bottom, limit as b approaches infinity of 1/2 natural log of b squared minus 1/2 natural log of 2 squared. Okay, as b goes to infinity, natural log of b also goes to infinity. So since this is going to infinity, we know it diverges. So because the integral diverges, we know that this series that matches it also diverges. This should be a 2. Well, actually, it can be a 1. It doesn't change our answer, though. Sorry about that. Because it didn't matter back here whether what we plugged in the number anyway. Should have been 1, though. I apologize. Because once this one went to infinity, it really didn't matter. So this one does, oops, sorry, wrong way. It does diverge by the integral test. Number 3 is a p-series, and we see that the power is 3. Since the power is bigger than 1, we know this one converges as a p-series. Okay, number 4, it's not a p-series, it's close to 1, but it's not 1, so we're going to have to use the integral test. we're going to change this to the limit as b approaches infinity from 1 to b of 2 over 1 plus x squared dx. This is actually an arctangent. I know that because the power on the bottom is 2, the power on top is 0 as far as x's are concerned. And when the powers are different by more than 1, it tends to be arc sine, arc cosine, arctangent. I know this one's arctangent because it's got a plus and it has no square roots. So let's look at the rule for arctangent. Okay, so it looks like a squared is equal to 1 this time, which means a is 1. Square root of 1 is 1. U squared is equal to x squared, so u is equal to x, just taking the square root there. Du is equal to 1 dx. Well, that doesn't quite match what we have over here. We have a 2 dx, so we need to multiply both sides by 2, so that we put a 2 du in here, and if we multiply by 2 on the left side of the equals, we're going to have to multiply by 2 on the right side of the equals. So now we can plug it in, 2 over 1, so that's just 2. Arctangent of u is x, a is 1, so arctangent x. And sorry, we don't need plus c because we're actually doing this from 1 to b. We do the limit as b approaches infinity. Limit as b approaches infinity of 2 arctangent of b minus 2 arctangent of 1. Okay, so 2 second tangent of x minus 2 second tangent of 1. We want to see what happens as we go to infinity. This is clearly going to a single value. It's actually going to pi over 2, if you care to know. So this is going to pi over 2, which means that we have an actual sum, and that means that the integral converges, which means that the series also converges. Okay, last one for this video we're going to look at down here. Ask whether this converges or diverges. So this is clearly not p series, so we're going to have to do integral test again. We do the limit as b approaches infinity, the integral from 1 to b of 1 over x squared cosine of 1 over x dx. Our u is going to be the 1 over x, or if it helps you write it as x to the negative 1. The derivative of that is negative x to the negative 2. Remember, multiply by the exponent, subtract 1, which we could rewrite as negative 1 over x squared. So hopefully now you're seeing why this matches. We have 1 over x squared right here. We just need to move the sign by multiplying both sides by negative 1. So now we get the limit of negative 1 to b cosine of u du. The integral of that is negative sine u from 1 to b. So that would be negative sine of 1 over x from 1 to b. And our last step is to plug in the top minus the bottom and then take the limit. So negative sine of 1 over b minus negative sine of 1 over 1. Okay, two negatives make a positive, so I'm just going to write plus sine of 1. And as we go to infinity, you can tell this is approaching a specific value, whatever that 0.841 is. So this is approaching a single value, which means this converges. And if the integral converges, then the series that looks like it also converges. Okay, that's all for this video. We'll do the other two sections in part 2.